Hi everyone, in today's lesson we're going to talk about applications with determinants. So the first thing that we can do with determinants is find the area of a triangle, given three vertices. So for example, I could ask you to find the area of a triangle whose vertices are 1, 0, 2, 2, and 4, 3. Now, if you learn nothing about determinants, you would solve this using a geometric approach by boxing out and finding the area of the shaded region. So what do I mean by that? You would plot your points, so you would plot 1, 0, 2, 2, and 4, 3. And then you would connect the points to create a triangle. And since it's not a right triangle, we can't use the formula A equals 1/2 base times height. Or just in general, in order to use this formula, you need some base here, and you need some height that you could measure. Or you would have to be given a formula or question like this with the height given and some base here. So since we don't have that, we have to find a different approach to finding the area of this triangle. And the approach of what I speak about is called a boxing out method, where I want to find technically the area of this triangle that is made up of those three vertices. And the best way to do it is to box out and find the area of the shaded region. So we can actually find the area of this box or rectangle that I just found minus the area of the triangles, and that'll give you the area of my shaded region. So the area of this box here is 1, 2, 3 by 1, 2, 3. So it's a 3 by 3. So the area would be 9 units squared. Minus, now I'm going to subtract off the area of this triangle here, this blue area. Now I can do that because the base is 1, 2, 3 and has a height of 1, 2, 3. So I'm going to subtract off 1/2 base times height. And then I can do it again here. So that has a base of 1 and a height of 1, 2. So minus 1/2, a base of 1, a height of 2. Then I can do it here. This has a base of 1 and a height of 2 as well. And I have this little box here, which is just an area of 1. So minus 1. So I put all that together, so this shaded region here, and I will subtract the area of the box minus all of these pieces, and I'll get the area of that triangle. So let's see what we got here. We have 9 minus 9/2 minus 1 minus 1 minus 1. Okay, so if you do this algebra, you should come out with the area of that shaded region, which should be 3/2 units squared. That's usually how we represent area. Okay, so now what I would like to do is show you the precalculus approach using determinants. So the area of a triangle whose vertices are given, x1, y1, x2, y2, and so on, is found by using this determinant. So we take plus or minus 1/2, the determinant of this matrix, and the plus or minus indicates the appropriate sign that should yield a positive area. So what I would do for proper notation is to write this as a determinant. I kind of wrote it as a matrix, but that would help us understand what we're doing. So I'm going to start by writing all of the points that I had before. So we had the point 1, 0, we had the point 2, 2, and we had the point 4, 3. So to find the area of this triangle that has those 3 points, we're going to find the determinant of the matrix that looks like such. So x1, x2, x3, so 1, 2, and 4, will go in the first column. Then the y values, 0, 2, and 3, and then 1's all along. And we need to find the determinant. So now remember, when you're finding the determinant of a 3 by 3 matrix, you can expand along any row or column you choose. So I'm going to choose to expand along row 1. So remember the rule is we multiply the cell value or the element here by its cofactor. So let's find all 3 cofactors. So C11, we need to find C12, and we need to find C13. So remember the cofactors for C11, we wipe out all this, and we're taking the determinant of this matrix. So 2 times 1 minus 3 times 1. So 2 times 1 minus 3 times 1. And that just becomes 2 minus 3, which is negative 1. Now if I want to find C12, row 1, column 2, we're going to wipe this one out and this one out. So 2 times 1 minus 4 times 1. So that just becomes 2 minus 4, which is a negative 2. And the last one is we're going to wipe this out, so this row and this column. So we're going to multiply 2 times 3, which is 6, minus 4 times 2, which is 8. So 6 minus 8 is a negative 2. Now just to finish off the cofactors, remember we need to keep in mind our sign chart. So take a look here. This is my sign chart. So plus, minus, plus. So this one is times a plus, this one's times a negative, and this one's times a plus. So we're going across, plus, minus, plus. So my cofactor is negative 1, positive 2, and negative 2. So now what we're going to do is we're going to multiply those cofactors by the elements in this first row. So 1 times negative 1 plus 0 times 2, this 0 times this 2, plus 1 times negative 2. So we have negative 1 plus 0 minus 2, which adds to a negative 3. So that is our determinant, which we have to now multiply by a half. So if we multiply it by a negative 1/2, then we get rid of the negative 3, which will make this a positive 3/2 units squared. And that's the same. Now notice I had to multiply this by the negative 1/2 because my determinant came out to be negative. You can't have a negative area, so that's why I had to select the negative 1/2. Okay, I'd like you to try one on your own. So moving on to the next page, I want you to try to find the area of the triangle whose vertices are 0, 1, 2, 2, and 3, 4. I actually just noticed that this should be 4, 3. So let's just change this to a 4, 3 and now complete the problem. Okay, so we want the area of this. So we're going to do plus or minus 1/2. And now the determinant. So I'm going to leave you to finish the rest and then hit resume when you're ready for the answer. Okay, here is your answer. Okay, so what I got when I did the determinant and found the area, I didn't even need to multiply it by a half because I realized that the determinant was 0. So when I have the determinant being 0, I can't multiply it by a half. So what conclusion do you think this makes? What you should have wrote is that if I have a determinant, so if the determinant equals 0, then there is no area. And if there is no area, there is no triangle. And if there is no triangle, these points lie on the same line. So these points are what we call collinear. Collinear means that they lie on the same line. So this is what I'd like to call a test for collinear points. So 3 points are said to be collinear if and only if their determinant, so make sure these are straight lines for determinant, if and only if their determinant is equal to 0. So let's test and see whether these 3 points are actually collinear or if they have an area and if they make up a triangle. So what we would do again is we would say, okay, the determinant is x values, so -2, 1, and 7. The y values are -2, 1, and 5, and then 1's down the last column. And let's check out to see what the determinant is. So I'm going to find it the same way, C11, C12, and C13. So I'm going to wipe out the first row, first column, so 1 minus 5 is -4. I'll wipe out the second row, so 1 minus 7 is equal to -6. And I'll wipe out the last, so 5 minus 7 -2. And let's test my signs, so positive minus positive. So we've got ourselves plus minus plus. So plus minus plus. So -4, 6, and -2. Now, to find our determinant, we're going to multiply them by the top row. So we've got here -2 times -4 plus -2 times 6 plus 1 times -2. So this is 8 minus 12 minus 2. So what do we have here? Excuse me, -8. Nope, it's positive, sorry. So 8 minus 12 is -4, and -4 minus 2 is -6. So our determinant did not equal 0. So since that was the case, these points are not collinear. So you would say these points are not collinear because the determinant did not equal 0. If the determinant equals 0, then that would be collinear. Okay, that's it. Jot down any questions that you might have, and we'll see you in class tomorrow. Have a good night.